2 minutes is for revision, 2 minutes is for doing the question. Assalamu alaikum, Nabil. How are you?
Walaikum salam, sir. I'm fine. What about you?
I'm good, man. How was your Eid?
Yeah, it was good, sir. Yours?
Good. Mine was very good. But
Eight.
approximately 50 more seconds. Here. So first of all, what do we have here? We have PCl5. So PCl5 is what? Number of valence electron in phosphorus is 5. And all of these valence electrons are being used in what? In the bonding, because 5 bonds we are having. So that means we are going to have 0 non-bonding electrons. And if I have 5 as the steric number, then my shape will be, the shape of PCl5 will be trigonal bipyramidal, TBP. So for A, we have trigonal bipyramidal A4. We have two options for A4, A and B. So both of these are possible. If I look at B, both of these are having 3. So I will move on to the C1. C may here we have SF6. Sorry, not C. C may we are having. C may we are having BRF5. So BRF5. So bromine has 7 electrons, 5 electrons are present. If I divide, then I will get 1. That is 1 lone pair. So we have 5 bonds plus 1 lone pair. Plus 1 lone pair. So 6. So that is why the steric number is equal to 6. So when steric number is 6, the hybridization is going to be sp3d2, right? sp3d2. And in sp3d2, we have octahedral. But in octahedral, we have one lone pair. If we have one lone pair in octahedral, it will be what? It will be it is A4 and C1. So C1 is option number B. My voice cracking? Is it cracking for you also, Nabil?
Yes, sir.
Yes. Is my voice cracking for you?
No, sir, no.
So, just give me a second. I'm audible clearly, right? Nabil?
Yes, sir.
How is it now? Is it fine now?
Yes, sir.
Yeah. So as I was saying, for BRF5, the shape is going to be what it is going to be, square pyramidal. So for C, it will be 1. Trigonal plane तो होता है 3 चाहिए उसके लिए pair. So B is the correct option. Now moving on. Try this. You have to give the hybridization of the F3 and the number of electrons around the central atom. Got one answer. So BF3 is quite easy. We have boron. First of all, BF3. Calculate the number of valence electron in boron. So we have what? Hydrogen, helium, lithium, beryllium, boron, right? So the atomic number of boron is going to be what? Hydrogen, helium, lithium, beryllium, hydrogen, helium, lithium, beryllium, boron, 5, right? So 5, that means number of valence electrons is going to be 3 because 2, 3 type of configuration. And all of these 3 electrons are being used in bonding. So the hybridization is going to be sp2. Now for sp2, we have either A option or we have the D option. Now, there are two ways in which you can understand that the electron that we are going to have in BF3 is 6. One is the question itself, because it is saying electron deficient. If something is electron deficient, it will not have 8 electrons in the valence shell. And how BF3 is having 6 electrons? Quite also simple. B and 3 fluorine atoms. So the central atom, it is having what? 1, 2, 3, 4, 5, 6 electrons. So sp2 is the hybridization and 6 is the number of valence electron around the central atom. Not valence electron, but number of electrons around the central atom. चलिए, moving on. बस एक चीज ध्यान रखिएगा, like for example, if I talk about boron atom, then the boron atom is having only 3 electrons. But when I talk about the boron atom in BF3, then the boron atom is having 6 electrons around it. Okay, in the molecule. If I talk about the atom, then the atom is having only 3 electrons. But when I talk about the boron in the BF3 molecule, then it is having 6 electrons. You try this. Which of the following molecule is non-polar in nature? Here also you have to apply the same hybridization and everything, because if you have something like this A and you have completely symmetrical structure like this, so it is symmetrical, so the dipole will be what? 0. Similarly, this is also symmetrical if I take tetrahedral case. Right? So you have to say which of them is symmetric. So try it, like calculate the hybridization in the shape and you will understand the story. इस नॉन पोलर बोला है ना, तो इसमें से आपको बताना नॉन पोलर कौन सा होगा. You take 1 more minute for this and then I will explain it. Okay, Nabil. Both of you gave the answer. That's very big. Both of you guys are correct. Now, I will tell you guys a one very simple thing by which you can say if something is polar or non-polar. Simple rule is that atom should have no lone pair, lone pair होना चाहिए, and all surrounding atoms should be. There will be a high dipole moment in the direction where lone pair is present. And if this all surrounding, in that case also what's going to happen, in that case also, you will have some atoms more electronegative and उस तरफ आपके पास polarities ज़्यादा होगी. In this case, what I see, I will see the compounds in which we have same surrounding atoms. We don't have any different surrounding atoms. We have two cases, that is NO2 and SpCl5. If I look at PCl3, then here we have phosphorus as the central atom, oxygen, including these are different atoms. These are not surrounding atoms, so this cannot be non-polar. Even CH2 and oxygen. So we have carbon as we have double bonds. Again, we also can also not be non-polar. This will also be polar. Now that's our two left. We have to see whether the NO2 is having any lone pair or SbCl5. Without any charges. It has O negative, the nitrogen will be having a positive charge, and it's a reactive bond kind of thing. So at this point, it will be one lone pair, right? And that's why the structure of this will be what it will be slightly bent. Nitrogen, oxygen, oxygen, and there will be lone pair links. And because of this lone pair, there will be not net dipole moment, zero will not be there. You will have some net dipole moment. So mu will not be equal to zero. Now we have SbCl5. If I look at SbCl5, then Sp is coming in what? Right. So nitrogen family. Nitrogen family is having valence electron. Valence electron is equal to 5. Surrounding atom is also equal to 5. So when both of these are same, that means we don't have any lone pairs, zero lone pair. If we are having zero lone pair and all the surrounding atoms are same, it is what is going to be nonpolar. For example, the structure will look something like this. Sp will have the 3 chlorine atoms and 2 chlorines here. So this is the whole structure of SbCl5. Now in this case, if you see, there will be an dipole moment which will be cancelled by an dipole moment here. The above dipole moment will be cancelled by the below dipole. So Sb5 will be correct. Both of you gave it correctly. Try this also. It's a very simple question. Which of the following set of molecules have zero dipoles? Again, you have to see the same zero lone pair and all surrounding atom are same. If they satisfy this, that's all. Okay. Very good. Just I'm letting you know, like for example, if they're writing hydrogen, hydrogen is going to be H2, sodium is going to be F2, right? For this, you have to make the structure 1,3-dichlorobenzene. You have to make the structure. Take 1 more minute. One. Kiran has answered. Let's see. We have boron trifluoride, BF3, hydrogen H2, F2, CO2 1,3-dichlorobenzene. Now, obviously, this is not going to be net zero, right? The dipole moment here will not have zero value because it will be having some dipole moment. So these are the two dipoles we are having. If I resolve it, it will be somewhere like this. So I will say that this is not a correct option. 1,3-dichlorobenzene you have to be ABC. If I see here, here we have boron trifluoride, BF3, beryllium difluoride, BEF2, carbon dioxide, CO2, 1,4-dichlorobenzene. Cl and Cl. So this will be non-polar, the muret, because here we'll having one dipole, here you will having one dipole, both of these will cancel each other. Now let's look at the rest of the molecules. So boron, valence electron 3, surrounding atom 3. All the surrounding atoms are same. Beryllium, number of valence electron is 2. The surrounding atom is also 2. So no, there is no lone pair and all the surrounding atoms are same. Carbon dioxide, you please see here, carbon dioxide, it is what? If you see, you write it like this, CO, but oxygen, it has valency that is 2, right? Double bond hota hai. That is why carbon, all the 4 bonds are used in bonding. So there is 0 lone pair in CO2 also. So the C option is correct. All of the compounds are what? Non-polar. If I look at ammonia and everything, so ammonia is going to have a lone pair, right? NH3. Ammonia has 5 valence electron, of which only 3 is being used as bonding. So there is one lone pair. So obviously there will be a dipole moment which is like this. So this cannot be true. The correct option is what? The correct option is going to be the C option. Please copy this down. Now moving on. Before I move on to this bond angle type questions, let us first of all see what are the factors that affect bond angle. Okay. The first thing that you have, this is sequence. Like you have to first see hybridization, then the number of lone pair, the type of central atom, then the type of bonded atom. All of these things will be there, but you have to see first hybridization, then lone pair, all of these things. Now, if I look at the hybridization, then the bond angle is directly proportional to the percentage of S character. That is, S character घटता जाएगा, है ना? And obviously that happens because, for example, और बढ़ता जाएगा जैसे SP है, SP2, फिर उसके बाद SP3. As we see, SP में 180 है, SP2 में 120, and SP3 में is 109.28. So higher the steric number, you can see that. And I can also write the bond angle. It is inversely proportional to the steric number. Because SP में steric number 2 होता है, SP2 में 3 होता है, और SP3 में 4. तो जैसे जैसे steric number बढ़ रहा है, वैसे वैसे sorry, the bond angle is what? It is decreasing. Make sense? Yes or no? Please tell me. सीधा क्या देख लीजिए, bond angle is inversely proportional to steric number. Next is when number of lone pair. अब यही देखिए, when hybridization is same. When you have hybridization same, उसके बाद फिर आना है lone pair one pair पे, ठीक है? So bond angle is inversely proportional to lone. Now, if you have high lone pair, the bond angle will be lower. वो कैसे होता है? For example, if you have something like this, you have one lone pair. One lone pair is repelling these two, and it is what? It is shortening the. If you have two lone pairs, so the bond and lone pair will be even more, and this will be getting shortened even more. So as we increase the number of lone pair, the bond angle is going to decrease. Next atom we are having. Again, here also you can see that the hybridization is same. The lone pair number of lone pair and bond pair is also same. Then the bond angle is directly to the electronegativity of central atom. For example, if I have NH3, PH3, ASH3, and SPH3, all of these are what? All of these are same hybridization, same number of lone pair. All of them are having one lone pair. Now, the bond angle will depend on the nitrogen atom's electronegativity. Why? Because if I have nitrogen atom and H3 this, here you will have lone pair, sorry, here you will have the electrons which move to and if the electrons are more towards nitrogen atom, then what will happen? They are closer. And when the electrons will be repelling each other more, and that is why when they repel each other, this bond will be going further away, this bond will be going further away. But that's not the case that is going to happen in the case of S3. Because in SBH3, the electron will not be near to sp, and that's why the electrons themselves will not be closer to each other. So bond angle will be directly proportional to the electron activity of the atom. And inversely, you can see that. The next is the type of bonded atom. So that if all of these are same, then we have to see the bond angle. It is directly proportional to the size of bonded species. Okay. You have to see the size of bonded species. For example, O2, OCl, and OBr. In that case, for example, oxygen have and you have fluorine atoms. Right. Now, fluorine is small, but have OCl. In that case, fluorine is large. So if fluorine is large, they will be repelling each other. And if they are going to repel each other, the bond will increase. Okay, so the type of atom is what? In fact, you have to see the size. Write this down, this whole thing, and then do this question. Okay, try this question now. The correct order for bond atoms in the following down. ओके लेट अस सी। सबसे पहले क्या देखेंगे, सबसे पहले देखेंगे हम लोग क्या, ऑल द स्पीशीज आर सेम ना, हाँ ठीक है। सो CO2 वगैरह से हम लोग स्टार्ट करते हैं। फर्स्ट ऑफ ऑल हाइब्रिडाइजेशन देखते सबका। सो हाइब्रिडाइजेशन फॉर CO2 इट इज गोइंग टू बी व्हाट, इट इज गोइंग टू बी sp, बिकॉज स्टेरिक नंबर इज 2, ऑक्सीजन के पास डबल बॉन्ड होते हैं। NH3 इज व्हाट, sp3, H2 इज sp3, NH4 पॉजिटिव इज sp3। तो CO2 का तो सबसे ज्यादा होना चाहिए, जिसमें A, B, C और D ऑप्शंस आ गए। ठीक है। नाउ आफ्टर दैट व्हाट वी हैव टू सी, आफ्टर वी हैव टू सी द नंबर ऑफ लोन पेयर। ठीक है। द बॉन्ड एंगल इज इनवर्सली प्रोपोर्शनल नंबर ऑफ लोन पेयर। अब लोन पेयर देखते हैं हम लोग।
So
NH3 में कितने लोन पेयर है, एक। एक सेकंड, इस फिर हम,
CO2 is sp2, right?
नहीं sp2 नहीं होगा, sp होगा ना। स्ट्रेक नंबर 2 है इसका,
Okay.
है ना, sp 180 डिग्री। In NH3 the number of lone pair is 1, H2 में 2 है और NH4 पॉजिटिव में 0 है। So from here also only we will get the answer. CO2 का सबसे ज्यादा, ठीक है। उसके बाद it is going to be inversely proportional number of lone pair, तो जैसे number of lone pair ज्यादा है, बॉन्ड एंगल कम होगा, तो CO2 के बाद CO2, उसके बाद होगा आपके पास NH4 पॉजिटिव, बिकॉज यहाँ पे लोन पेयर नहीं है, दैट इज व्हाई द बॉन्ड एंगल विल बी लार्जर। आफ्टर दैट यू विल हैव NH3, सबसे कम होगा H2 होगा, राइट। सो ऑप्शन बी इज करेक्ट आई थिंक, राइट। CO2 NH4 पॉजिटिव NH3, हाँ ठीक है। Yes, your answer is also correct. Now, in molecular orbital theory, yeah, दो केसेस है molecular orbital theory में, when you have the number of electron that is less than or equal to 40, then you have a certain configuration that you have to fill, और जब आपके पास number of electrons more than 40 हो तब आपको याद करना है, ठीक है। अब इसमें क्या हो रहा है, पहले उसको देख लेते हैं, फिर याद कैसे रखना है वो भी देखते हैं। टिल starting the same sigma 1 is sigma 1 star, 2s 2s star, then you will have pi 2px pi 2py. After you will have sigma 2pz, pi star to px, pi star to py, and sigma star to pz. That is the case when you have number of electrons that's equal to, याद रखने के लिए आप देखिए सिग्मा 2s सब तो यहाँ पे सिग्मा 1 स्टार, सिग्मा 2s, सिग्मा 2s स्टार, सिग्मा 2pz, pi 2px, pi 2py, pi star 2px, pi star 2py, सिग्मा स्टार 2pz। याद रखो सेम है बिल्कुल। उसके बाद when you are n is equal to or less than 14, तो 14 है आपके पास, तो 14 equal to 14, 14 is even, और even से याद रखिए 2, और आप कैसा फिल करना है, 2 1 2 1 2 1 2 1 2 1 2 1, not n is equal to 14 or less than that। when n is greater than 14, तो 14 से ज्यादा 15, 15 के लिए और के लिए याद रखिए 1 2 2 1। So here you are starting from sigma 2px, sorry, you are starting from pi 2p pi 2py, then sigma 2pz, then pi star, then sigma star। ठीक है, तो आपके पास पाई के दो आएंगे, then you have then pi and star and then star। In 1 to 1 to what we have to do, sigma, then pi star and sigma star। Sorry, not pi star, sigma, उसके बाद पाई, फिर पाई स्टार, उसके बाद सिग्मा स्टार, लाइक दिस। So pi sigma, pi star sigma, that is 2 1, that is 2 or molecular orbital, then 1 molecular orbital, then here also 2 molecular orbital, here 1 molecular orbital। ठीक है, तो इसको लिख लीजिए, और साथ में बस इसको आप लिख लीजिएगा, अभी एक्सप्लेनेशन देने का टाइम नहीं है, दैट व्हाट इज sp मिक्सिंग, बट समटाइम्स दिस कैन बी आस्क्ड इन लाइक जो ABCD टाइप का सवाल, उसमें sp मिक्सिंग नॉन नो sp मिक्सिंग सर्च लिखा जा सकता है, ठीक है। So this is also there in NCERT. I mean, this line is there due to sp mixing and no sp mixing। इसको लिख लीजिए प्लीज, प्लीज राइट दिस होल थिंग डाउन। Raise your hand once you're done। Yes, sir. Just give me a second. Okay. After this, we are going to do two cases. One is for nitrogen N2, and then we are going to do for O2. After that, we'll look at some questions. Okay. Now, since we are at N2, we will take three cases: N2, N2 positive, and N negative. Okay. So, two, how many electrons we are having? 14 electrons, right? So we are going to take the case of 14 electrons, even though in N2 we have 14, in N2 positive we have 13 electrons, and in N2 negative we have 15. ठीक है, तो ये 15 देके आप मत कर लीजिएगा. Take the base molecule, that is N2. N2 is what? N2 is 14. So अब 14 वाला configuration ही हम लोग लेके चलेंगे. In that we are going to add one electron. Now if I start from the lowest, then we will have sigma star. इसको भी ना ऐसा रखते हैं. So we are starting from sigma 1s, then sigma star 1s, then sigma 2s, then sigma star 2s. उसके बाद क्या आएगा? Pi आएगा. So we'll have pi 2px, pi 2py, then sigma 2pz, उसके बाद pi star, then sigma star. Now I will fill the electrons. Now how I am going to fill the electrons? I will add two electrons in each molecular orbital. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. अच्छा 9, 10 ऐसे नहीं होगा by the way. We'll have 9 electron, and because both of these are in the same energy level, it will not pair. First of all, I will fill this half, and then I will start pairing like this. So here we are having 1, 2, 3, 4. So this is 8, 9, 10, 11, 12. Two more electrons, 13, 14. So we are having 14 electrons here. Okay. Now, first of all, we will look at the magnetic behavior. So magnetic behavior में दो cases होते हैं. Either it will be diamagnetic or paramagnetic. इसके बारे में बताइए. It will be dia और para. कुछ याद हो तो अरम dia और para के बारे में. So it will be diamagnetic or paramagnetic. And diamagnetic, yes, because we have all the electrons are paired. So magnetic behavior is what it is? Diamagnetic. Fine. Number of bonding. So bonding is where you don't have star, है ना? जहां जहां पे star नहीं, वो सारे क्या हो जाएंगे? Bonding हो जाएंगे. If I look at the bonding, so this is bonding, this is anti-bonding, this is again bonding, this is again anti-bonding. Both of these electrons are what? These are bonding, bonding, and sigma 2pz is also bonding, right? So number of bonding electrons, how many we have? We have 1, 2, 3, 4, 5. 5 orbitals, that means 10 electrons are bonding. Make sense? Yes or no?
Yes.
Now, once you have got the bonding, no need to count the anti-bonding because total we had 14. 14 में से 10 bonding है, तो 4 क्या हो जाएंगे? Anti-bonding. Make sense? अब bond order के लिए क्या करना रहता है? Bond order is very easy. Bond order, it is equal to, ये थोड़ा याद आ जाएगा आप लोगों को, bonding minus anti-bonding divided by 2. ठीक है? So 10 minus 4 is equal to 6. 6 divided by 2, it is equal to 3. ये बॉन्ड लेंथ, बॉन्ड स्ट्रेंथ, बॉन्ड एसोसिएशन एनर्जी एंड एक्जिस्टेंस के बारे में, इन तीनों के बारे में बाद में बात करेंगे. आई विल कंपेयर N2, N2 positive and N2 negative. We can talk about the existence of N2. It is going to exist. Why? Because two nitrogen atoms are having 3 bonds in between. If bond order is greater than 0, then only the molecule is going to exist. अब हम लोग देखते हैं N2 positive के लिए. In N2 positive, what should happen? We have to remove one electron. So I will remove one electron. Now, what is it? Paramagnetic or diamagnetic?
Para.
Number of bonding electrons? 10 था. 10 अभी हमने निकाला कहां से? देखिए, आई हैव रिमूव्ड फ्रॉम द बॉन्डिंग, है ना? तो 9 हो जाएंगे. मेक सेंस?
Yes.
वी हैव नॉट टच्ड एनीथिंग फ्रॉम एंटी बॉन्डिंग, तो एंटी बॉन्डिंग वही 4 रहेगा. मेक सेंस?
Yes.
अब बॉन्ड ऑर्डर कितना हो जाएगा? बॉन्ड ऑर्डर कितना हो जाएगा? 9 minus 4? 9 minus 4 is how much? 11? 5. 5 by 2?
Yeah.
Sorry? अच्छा एक बात बताइए आपके ऐसा कॉन्स्टेंटली क्यों आ रहा है मतलब पंखा चल रहा है कुछ ऐसा चल रहा है क्या इस वजह से आ रहा है या ईयरफोन आपने प्लग
I don't know. ये खराब है.
सो टेल मी बॉन्ड ऑर्डर कितना हो जाएगा फिर
5/2.
5 by 2 2.5
सर आवाज नहीं आई आपकी.
molecule is going to exist yeah I'm saying 5 by 2 2.5
Yes sir.
5 by and existence ये exist it will going to exist अच्छा N2 नेगेटिव में ध्यान रखिएगा इन N2 नेगेटिव फर्स्ट ऑफ ऑल N2 है अभी आपके पास we add one electron now it is N2 I will add one electron so the electron is going to going higher level that is pi star to the x so now we are again para now the number of bonding we have not disturbed any bonding number of bonding is still 10 as was the case for N2 but we added one electron which is in the anti-bonding so it is going to be 5 here the bond order is going to be 2.8 existence this is also going to exist if I look in this case first of all you have to see the bond order bond length it is inversely proportional to the bond N2 will have
Sir,
the
your voice
smallest
is
bond length
breaking.
Excuse me. How is it now? Any better? Let me just read a few things.
Yes.
Magnetic behavior, number of bonding, number of anti-bonding, bond order, bond length, bond strength, bond dissociation energy, existence.
Yes sir.
So bond length it is inversely proportional to bond order because जितना ज़्यादा bond order होगा, that means we are having more electrons atoms, and those electrons are responsible for attracting the atoms. So if you have more electrons in between, then the electrons will attract both the atoms, make bond length small. जैसे भाई सिंगल बॉन्ड लगा होगा डबल बॉन्ड तो दो बॉन्ड दे विल बी क्लोज तीन बॉन्ड तो ज्यादा वही बॉन्ड ऑर्डर वही होता है 2.5 2.5 यहाँ पे बॉन्ड ऑर्डर इज गोइंग टू depend on exactly like the pure bond order is going to depend on anti bond अगर anti bonding ज्यादा होगा then in that case bond length will be smaller so we will have N2 positive and सबसे ज्यादा किसका होगा N2 negative का because the anti bonding number of anti bonding electrons is more here in this case अच्छा अब bond strength जो होगी तो bond strength it is going to be again inversely proportional to the bond strength it is inversely proportional to the bond length because bond length जितनी छोटी होगी उसको तोड़ना मुश्किल होगा so you will have N2 will be having highest then you will have N2 positive and then you will have N2 negative अच्छा same is the bond dissociation energy that is the energy so you will have N2 highest then you have N2 positive and then you have N2 negative please copy this down raise your hand once you're done नेक्स्ट इज O2. ठीक है, तो O2 में हम लोग देखेंगे we have going to see 5 cases here. That is O2, then positive and 2 positive, negative and 2 negative. In the case of O2, we have how many electrons? We have 16 electrons because each oxygen atom is having 8 electrons. So when we have 16, that is more than 14. So we are going to have 1, 2, 2, 1. Now here we are going to fill the electrons similarly. So we have 16 electrons to fill. I will first of all see the case of O2, and then I will take the case of O2 positive and negative. 2 positive and negative. So 16 electrons, 1, 2, this one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. ठीक है? Now O2 is what? O2 is, tell me, para or dia?
Para.
Very good. So the magnetic behavior is para. Number of bonding, how many? Yes, please count. How many bonding? Sorry. Yes, Ram, how many bonding? आवाज आ रही है आपकी?
Sir, I can't hear you.
You can't hear me. I'm asking how many bonding electrons are?
Okay.
ये बताना ये.
4.
Tell me.
4.
4. 4. जी रम.
Sir, 10.
बॉन्डिंग देखना, बॉन्डिंग 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 काउंट करें ना. हाउ मेनी बॉन्डिंग इलेक्ट्रॉन्स? 2, 4, 6. व्हाट इज हैपनिंग?
10, sir.
हाँ 10. वेरी गुड. 10 उससे ज्यादा नहीं है. देख लीजिए एक बार. पक्का 10 ना? ठीक है, एंटी बॉन्डिंग बताइए. 16 थे तो एंटी बॉन्डिंग कितने हो जाएंगे?
6.
6. बॉन्ड बताइए. व्हाट वुड बी द बॉन्ड नाउ?
4.
बॉन्डिंग माइनस एंटी बॉन्डिंग डिवाइड बाय 2. जी एक बार फिर से बोल दीजिएगा, आवाज नहीं आई. सॉरी.
2.
2 है ना, एग्जिस्ट करेगा. सही है ना. अब एक इलेक्ट्रॉन हम हटाते हैं यहाँ से. ठीक है, तो अभी भी नाउ इट इज व्हाट 1. आई हैव रिमूव्ड 1 इलेक्ट्रॉन, इट इज व्हाट O2 पॉजिटिव. इट इज स्टिल व्हाट para. I have removed from anti bonding, so number of bonding will be still the same, that is 10. Number of anti bonding will be 5. The bond order will be 2.5. Existence होगी O2 2 positive में. I will remove once again. कर लेंगे इसको कंप्लीट. ठीक है, करके आप ना बॉन्ड ऑर्डर तक हमको भेजिए, उसके बाद का डिस्कशन हम देख लेंगे. ठीक है, सेंड मी टिल बॉन्ड ऑर्डर. ये ना, ये डाया हो जाएगा बस. अब इसको कंप्लीट कर लीजिए. ठीक है. And once you are done writing this, you can send me, please send me on WhatsApp this whole thing. Yeah, I've seen. ठीक है check कर लेते हैं इसे. So auto positive में each will be 10. This will be 4, so this will be 3. Will be existing. ठीक है. जीरो बॉन्ड ऑर्डर कैसे हो जाएगा? उसका जीरो नहीं होगा, जीरो कर दिया. This will be para and number of bonding this will be same. Bonding कुछ नहीं करेंगे. I will add one more electron, तो ये 7 हो जाएगा, so it will be 1.9. The existence will be still there. This will be dia because pair हो जाएगा वहाँ पे 10 and this is going to be 1, not 0. Existence is कभी होगा, है ना? Now we can talk about the bond length. So we have seen that bond length is what? It is inversely proportional to the bond order. So O2 2 negative का bond सबसे क्या होगा? सबसे ज्यादा होगा. Then you'll have O2 negative. Then you'll have O2. Then you will have O2 positive. Then you will have O2 2 positive. Bond strength is inversely proportional to bond length. जिसका bond length ज्यादा, उसका जिसका bond length ज्यादा, bond strength उसका कम. So O2 2 negative, then O2 negative, then O2 and then O2 positive, and then O2 2 positive. Bond association energy में भी same रहेगा. O2 2 negative, O2 negative, O2 positive, and O2 2 positive. ठीक है, so copy कर लीजिए. Raise your hand once you're done. Which of the following diatomic molecular species has only 5 bonds according to the molecular orbital theory? 5 bonds का मतलब जैसे for example, if you see here, O2 में देखिएगा, ठीक है ना? ध्यान से देखिएगा O2 में. All of these bonds are getting cancelled by each other. Means sigma 1 जो है bonding, वो anti bonding उसको cancel कर दे रहा है. Sigma 2s वाला को sigma 2s star cancel कर दे रहा है. If I look at the pi sigma 2 pz and pi, then इनको cancel करने वाला नहीं है कोई, right? I mean, हाँ वो हमने हटा दिया है. For example, these were there. So the orbitals responsible for the bonding are what? These two. Because इनको तो सारे cancel कर दे रहे हैं. यहाँ पे एक आपके पास सिग्मा बॉन्ड बनेगा और एक आपके पास क्या बनेगा? पाई बॉन्ड बनेगा. तो जो दो बॉन्ड्स होंगे O2 सिग्मा, द अदर भी पाई. ठीक है. इस केस में थोड़ा देखिए, ट्राई टू डू फॉर एग्जांपल कार्बन पे 12 होते हैं, ठीक है. देन बेरिलियम में कितना हो जाएगा? बेरिलियम विल बी हैविंग 8, ये 16 और ये 14. सो डू द मॉलिक्यूलर ऑर्बिटल कॉन्फिगरेशन थिंग. कार्बन के लिए E2 के लिए O2 के लिए, ठीक है. उसके बाद बताइए that which of the orbitals, which of the compound is going to have बॉन्डिंग ओनली बिकॉज ऑफ पाई और मॉलिक्यूलर ऑर्बिट, सिर्फ पाई की वजह से वहां पे बॉन्डिंग होगी, सिग्मा की वजह से वहां पे बॉन्डिंग नहीं हो रही होगी। ठीक है, इसको कीजिए, मतलब वन सी डू ना सिग्मा माइनस टू, तो फिर आपको आ जाएगा। थोड़ा टाइम लगेगा इसमें, बट यू विल डू इट। ठीक, 1 more minute। फिर देखिए, तो एक ना एक एडवाइस आपको ये देंगे, बट सिंस वी नो इन बोथ द केसेस वेदर इट इज मोर देन 14 or it is equal to or less than 14, the sigma 1s, sigma 1s, sigma 2s, sigma star 2s, like this is same in all cases, and all if you are going to add electrons here, it is going to cancel it off, सारे electrons क्या हो जाएंगे, cancel। so in that case you have to do, if you want to do anything in molecular orbital theory, आप 8 इलेक्ट्रॉन के बाद फिर कीजिएगा। ठीक है, रिमूव द 8 इलेक्ट्रॉन्स एंड देन यू स्टार्ट डूइंग एनीथिंग, बिकॉज 8 इलेक्ट्रॉन तक तो सब कुछ कैंसिल हो रहा है। उसके बाद आप अब आपको देखना है, फॉर एग्जांपल वी हैव C2 12, 12 में क्या होगा? इट इज लेस देन 14, तो 14 के लिए क्या करते हैं हम लोग? वी हैव 2 1 2 1, we have 2 1 2 1, right? So how many electrons are left? 4 electrons are left, and we are going to add all the 4 electrons where we're going to add the 4 electrons here only, because here we are having 2 more orbitals, pi star, pi and pi 2 respectively, 1 2 3 4, right? And the bonding will be only because of these two. यही हो गया C2 इज व्हाट? देखिए, B2 में 8 इलेक्ट्रॉन जाएंगे, ये केस हो सकता है। O2 में 16 है, 16 के बाद हम करते हैं 8 बचे, 8 के आपको क्या करना होगा? 1 2 2 1, so you will have 2 electrons, here you will have 4 and here you will have 2. So obviously the bonding will be because this is bonding, and these two are star molecule orbitals. So the bonding will be because of these two, and this is having sigma and pi, both of them. N2 में भी आपके पास एक सिग्मा 2 पाई होगा, तो A is the correct answer. Which among the following is incorrect?
B.
Okay. Didn't get any notification. A है या D?
तो इनकरेक्ट है ना, तो B.
Incorrect statement. Bond order of O2 positive, O2 negative, and O2 2.5 to C2 electrons and H2 H2 positive has 1 electron. O2 positive is diamagnetic, O2 positive is paramagnetic. So this option is correct. Try this one. Identify the molecule does not exist. में क्या होगा? Bond order will be equal to 0. And the answer, yes, correct, very good. Kind of makes sense because helium is a noble gas. Try this. Consider the following species: CN positive, CN negative, NO, CN. Which one of these will have the highest border? तो यहाँ पे बस आपको एक चीज ध्यान रखना है. Count the number of electrons है ना CN में. CN में कितना होगा इलेक्ट्रॉन्स होंगे एंड अकॉर्डिंगली या तो नाइट्रोजन जैसा होगा या तो ऑक्सीजन जैसा होगा. ठीक है. सो इफ इट इज CN, ठीक है, CN का लिखिएगा. इफ इट इज लाइक नाइट्रोजन तो फिर आप क्या कीजिएगा, द नाइट्रोजन यानी 14 से लेस होगा इसका, तो फिर आप नाइट्रोजन वाला केस ले लीजिएगा. इट इज मोर देन 14 तो फिर आप उसको ऑक्सीजन वाला केस लीजिएगा. काउंट फॉर CN, उसका CN पॉजिटिव नेगेटिव के साथ खेल सकते हैं.
हाँ. I should calculate the bond order for CN.
CN नहीं, आप नंबर ऑफ इलेक्ट्रॉन्स काउंट कर लीजिए CN के लिए, फिर आपको पता चल जाएगा N2 वाला केस लेना है या O2 वाला केस लेना. तो CN में कितने इलेक्ट्रॉन्स होते हैं? बताइए. कार्बन में होते हैं 6, नाइट्रोजन में होते हैं 7, कितना हो गया 13.
Yes.
तो लेस देन 14 तो N2 वाला केस होगा, है ना.
Yes.
अब सुनिए जरा, अब CN पॉजिटिव में क्या होगा, यू विल हैव 12. CN नेगेटिव में कितना हो जाएगा 14. तो 14 तो बिल्कुल कैसा हो गया N2 का केस. और N2 में कितने होते हैं बॉन्ड, बॉन्ड ऑर्डर होता है 3. CN पॉजिटिव के लिए क्या हो जाएगा बॉन्ड ऑर्डर, 2 इलेक्ट्रॉन आप अगर हटा देंगे 2 हो जाएगा. CN positive जो है ना, CN positive, it is the case where we are having 2 electrons removed from the nitrogen. ये नाइट्रोजन हमारे पास, नाइट्रोजन से अगर हम ये दोनों इलेक्ट्रॉन को निकाल दें और बॉन्ड ऑर्डर क्या हो जाएगा, घट के 2 हो जाएगा ना.
Yes, sir.
समझे कि नहीं समझे?
Yes, yes, sir.
ठीक है. क्या बोला इन्होंने, जब हाईएस्ट बॉन्ड ऑर्डर तो 3 है, उसके बाद आई थिंक फिर तो CN नेगेटिव ही हो जाएगा. जब 3 से ज्यादा बॉन्ड ऑर्डर फिर CO पॉजिटिव का होता है, CO पॉजिटिव में वो 3.5 हो जाता. ठीक है. तो CN नेगेटिव विल बी द करेक्ट ऑप्शन. 3 से ज्यादा तो हो नहीं सकता ना. NO का देख लीजिए, CN दिया हुआ, CN will be 2.5 because it is between CN positive and CN negative. NO will be 7 plus 8, that is equal to 15. तो ऑक्सीजन वाला केस है एंड ऑक्सीजन NO प्योर ऑक्सीजन. ठीक है. तो इट विल बी 15 इलेक्ट्रॉन्स किसमें होगा, और O2 में होता है आपका 16. O2 पॉजिटिव is, हाँ O2 में 16, तो उसमें बॉन्ड होता है 2. और 15 के लिए O2 पॉजिटिव एंड O2 पॉजिटिव हैज बॉन्ड एंगल सिमिलर टू दैट, बॉन्ड ऑर्डर हो जाएगा 2.5, है ना. O2 पॉजिटिव का, if you remove one electron is removed from, है ना, O2 पॉजिटिव का 2.5.